Hello everyone. Today we are going to learn section 7.2, the normal distribution. Normal distribution, we talked a little bit last time, so it's a bell shape. So if we are using continuous number, we are using normal distribution. So normal distribution actually come from the bell shape, right? But then we can say that normal distribution is a bell shape, but we don't say that all bell shape is a normal distribution, right? Make sense to you? There's a difference between bell shape and then normal distribution, right? Yeah. So normal distribution, we say for bell shape with a continuous number, okay? All right. So we have a learning objective here. Okay, now the center is bell shape, so mean we are using as a center. Variation, since bell shape, we are using the standard deviation, right? And the shape of this distribution is normal, which is bell shape, right? Okay. Um, we have a standard normal distribution. So we using z-score. All right. So if we have a standard, yeah, basic standard normal distribution is a normal distribution that has mean equal to 0 and standard deviation equal to 1. So basically, the z-score is unilist, right? So we make a standardizing for everything, yeah, by using z-score, okay? But look, we are going to use StatCrunch for finding area and z-score, all right? Okay, so let us do this one first. This standard normal variable mean equal to 0, standard the deviation is the 1, right? So we want to find the probability. What's the probability? Z is less than 2.45. Z is greater than 0.81. And Z is negative 1.23 and 0.98. So let me take a picture of this. And then I'm gonna show you StatCrunch. Okay, let me stop here. And then share screen. I should make a share screen there first, huh? Okay. Hold on a second, sorry about that. Okay. All right, so this one. All right, so open StatCrunch. We're going to stack. There is a calculator and there is a normal. Can you see that here? All right. Stack, calculator, and normal. Yeah. Okay, let's click that. All right, so let me bring this one in the middle. Okay, so I took a picture. Um, so z-score is less than, okay, hold on one second, let me talk. We are using mean equal to 0. Standard deviation is 1 for standard normal distribution, right? And then this will be Z. Then Z is less than 2.45. And then I told you it does not matter equal sign, no equal sign in continuous, right? Because 2.0000001 is the same as 2, right? That's why we really don't care less than or equal to. Yeah? Make sense? All right. So the first question, what's the probability Z-score is less than 2.45? Yeah, so let's compute. So we get 0.99285719, right? Okay, so I told you probability is a very tiny number between 0 and 1. So let's answer at least 4 decimal places, right? So we say the 0.9929 because 5 is the same as 5. We give it to the 1, round up, right? We got that? Okay, let's move on. Second one is Z-score greater than 0.81. 0.81. Okay, compute. So we get greater than, sorry. Yeah, greater than, right? Greater than, yeah, 0.81. So we get 0.208. Oh, so 7 is greater than 5. So give it to the 1, then there is 9. So 10, so 2090 then, right? Make sense? Round up. If we want to answer 4 decimal places, right? Okay, good. The next one we have Z-score is between negative 1.23 and 0.98. So we can see that between there, here, can you see? Okay, so we click between, and this is Z-score here, right? Z-score, Z-score, different color. Z-score, Z-score. Okay, now Z-score is between negative 1.23, right? So negative 1.23 between and 0.98, right? So 0.98. Okay, compute. Yeah, okay. I did not mention about the area. Ooh. All right. So between, can you see that? The shading part with in red, right? So that's the between. That is actually Z-score. This is Z-score, right? Make sense? So Z-score is, we had that previously, is the distance in terms of standard deviation, right? So when we use position, we are using Z-score, right? So this is the same as we ghost mean equal to 0, then standard deviation is 1, right? That is like in bell shape, 1 standard deviation, 2 standard deviation, 3 standard deviation from the mean. Yeah, it goes the same, right? With the Z-score, same. Z equal to 0, Z equal to 1, Z equal to 2, Z equal to 3. You guys understand what I'm saying? All right. Okay, so, all right. Let me talk to one more time. So I did not mention the shading part. So let me go over 0.9929, right? So Z-score less than 2.49. Sorry about that. So Z-score less than 2.49, right? So let me do one more time. It's less than, not the greater than, less than, yeah? Yeah. Can you see the shading part in red? Almost everywhere, right? That's why 0.9929, because probability maximum is 1, right? Minimum is 0, right? So it's a 0.9929, almost 1. Can you see the shading part here? Everywhere, right? Except a little part is not shading, right? Okay. This is the one. All right. Now, second one, z-score is greater than point. So z-square is 0.81 greater than. Here is z-score. Z-score is 0.81, almost 1. And right side here, right? Okay. Let's take a look. Greater than 0.81. Compute. Okay, 2.2090, yeah? So that area, this area is 0.2090 and greater. So that part, right here part, right? Make sense? Okay. Okay, so we have another question. Find area left of negative 0.87. Find the area between 0.25 and 0.75. Find the area to the right of negative 1.52, right? So this is what we just did earlier, right? So this will be A is probability of z-score less than or equal to negative 0.87. And second one, probability of z is between 0.25 and 0.75. And the last one, probability of z-score is right. So greater than or equal to negative 1.52. Yeah. Do you want me show one more time for this one? Or you're okay? Okay, let me take a picture. I'm gonna show you one more time. Okay, so this time we have non-standard normal distribution. Means that if we had a standard normal distribution, then we are using mean equal to 0, right? Standard deviation. Sorry, standard normal distribution, right? Standard normal distribution. So we are using mu equal to 0, sigma equal to 1. Then we are finding z-score, or z-score is given, right? Z-score is given. And then we finding the probability, right? We did that earlier, right? How about what if we have non-standard normal distribution? What this mean? This means mean is given something different than 0 because we are using z-score, right? So z-score is number, so their mean equal to 0, standard deviation is the 1, right? So non-standard normal distribution we given mu equal to something and sigma equal to something. So think. And then we are finding x values. It's given, or find the probability, right? Or given probability, find the x value like that. So we can switch over. In the case, we can switch over too, right? All right, so let's take a look. So we have a z-score, the formula, right? Then we want to know about the x. How they find this x, right? Then we times sigma both sides, right? Then we simplify. Then we have z times sigma left side equal to x minus mu, right? And then we want to find x. We add sigma both sides. So there will be mu plus z times sigma equal to x. Yeah. So they have the same answer right here, right? So x equal to mu plus z times of sigma, right? I'm gonna show you how to do by hand, but we are using StatCrunch, all right? Yeah. Okay, so, oops, let me bring this one. Okay, so the first one, we have mu equal to 72, standard deviation is 8, right? Find z-score for x equal to 66. So z-score, we know that, right? X minus mu over sigma, right? Okay, so x in the case is 66, mu equal to 72 over sigma, which is 8. Can you please calculate? Negative 0.75. Yeah, z equal to negative 0.75. Yeah. All right, second part. Find raw score means x value. Yeah. Okay. So then we have a formula here, right? Or we can just derive a formula, that's fine too, from the z-score. But then since we have a formula, let's using that, right? So we have x equal to mu plus z times of sigma, right? All right, we want to find what is x. That's the raw score. The mu, which is 72 plus z-score 1.6, sigma is 8. What do you get? 84.8, right? Okay, the third one, find probability that x is less than 66, converting to the standard normal and using StatCrunch. Okay, so this means we are using StatCrunch. And what's the probability x is less than 66 by using mu equal to 72 and standard deviation is sigma equal to 8. Yeah. All right, let me take a picture. So let us do this one. Okay, now we have these questions. Consumers in the US replace their cell phones every 2.8 years on average. The mean of X is 2.8 years, and standard deviation for replacement is 1.1 years. And then they are normally distributed. We want to find probability, all right? What is the probability a cell phone is replaced before it's a year old, right? So we are using log mean equal to 2.8 years. Yeah. And then standard deviation is 1.1. And then we are using probability of X less than 1 year, right? And then we check the probability. If less than 0.05, that's unusual, right? If not unusual. Yeah. And then unusual. The probability is less than or equal to 0.05, right? Probability. How about that? Okay. Second one, at least. How do we indicate at least? At least. We are using a lot, so I told you, remember, right? So it's greater than or equal to 3 then. Yeah, we are using that. So mean equal to 2.8, standard deviation is 1.1, and between probability is between 2 and 3. Okay, more than 5. More than 5 is greater than without equal sign, right? So more than. Okay, so continuous, it does not matter. We have equal sign, no equal sign, right? So X is more than 5. Okay, let's do StatCrunch. Yeah, let me take a picture of this. Let me show you everything. Okay. Oops. Hold on a second. Okay, so let's talk about the unusual for the first one. So first one, what did we have? We have from previous one, we have a 0.0509, right? Round up. So 0.0509. Yeah. Okay. So is it unusual? It's tiny. Little bit more than 0.05. So this is not unusual, right? Because it should be less than or equal to 0.05, not unusual. Yeah. Okay. Okay. So we have a percentile with a normal distribution. So what we had a percentile before, right? So think of percentage, right? So percentage. Okay. Then with a normal distribution, we have percentile rank. So basically the probability, right? So if we have a probability, we can make a percentile. I mean, percentile. Percentile. Percentage, yeah? Mm. Okay, so K percent, right? K percent, percentile. And then they want to make a whole number percentage, yeah? Okay. We use probability. So missing X there. I mean, sorry, parentheses. And percentile always refers to the percent, probability, proportion, or area on the left. Yeah, because percentile we already we said before, right? Previously, at the percent or below, right? That's why. Yeah. Below or at. Below or at K%. Yeah. Okay. Now let us do this one. So mean SAT math score 528, right? Mean and sigma we have 120. Yeah. Mean sigma. And Samuel scored 435. There will be X. Okay. So what is percentile rank, right? So we make that means we want to know about the probability X less than or equal to 435. Yeah. And then second part, Hercules scored 647. What is the percentile, right? What percent of students scored better than Hercules, right? So probability of X is less than or equal to 647. Okay, let me take a picture and then I'm gonna show you StatCrunch. Okay, so let me read here. The first one, we would say that Samuels scored at the 21st percentile because 21.9% of students scored less than or equal to his score, right? Yeah, less than or equal to his score. We can say the 22% because the 21.9% if we make a whole number. We did earlier, right? Yeah. But he did not score better than 22% of other students. Yeah. Okay. How about second one? So yeah, why did not round up, right? So 83.9%, almost an 84%, right? Yeah. But then would say that Hercules scored at 83rd percentile. Not rounding up. 83% of students scored less than or equal to his score, right? And complement is that approximately 17% of students score better than Hercules. Yeah, we should round up, right? Yeah. So this is 84%. Yeah. So 84%. And this is a 16%. Yeah. Okay. Good. Very good. All right. So we have this equation. This question. Let's take a look. Same SAT math scores, mean 528, standard deviation 120. Now, what is 90th percentile for SAT math scores? Look, in that case, 90th percentile, what this mean? This means 90%, right? Which is 0.9. This is a probability, right? Okay, we have a percentile means that from below until yet, right? At the point 0.9, right? So we are using probability and X less than or equal to And then the probability is 0.9. And then we want to find what is the X value. Make sense? Now we're going to use a StatCrunch. Once again, the probability is given, and then we are using inequality is less than or equal to because it's a percentile, right? Percentile means always below or that point, right? At 90th percentile, right? So we make a probability is 0.9. This time we are finding the X value, which is math scores. Yeah. Okay. We're doing second. All right. So let us do this question. So we have the cell phone replacement times, right? Okay, so mean is 2.8 years, and then standard deviation is 1.1 years. Okay, the first one, what is the 25th percentile for cell phone replacement, right? So 25th percentile means, so p sub 25 equal to 0.25, right? So it's a probability, right? So we put 0.25 other side. So we want to find what is the X value, right? So P, X, and percentile, so less than or equal to, what's the X value? Equal to 0.25, right? Okay, what is the 90th percentile? Same. So that means the P sub 90th equal to 0.9, right? So what's the probability X? What is the X values, which is how many years for replacement, right? So equal to 0.9, right? Okay, third one, what cell phone lifespan is cut off for top 5%? So top 5%, let's take a look. So top 5%, it's about here, right? Top 5%. How do we indicate the top 5%? It's a 0.05. It's the top. Can you see that? The right tail, right? So we're using this inequality. X is greater than or equal to, and then the probability is 0.05, right? All right. Make sense? Because the right tail here, right? Top 5%. Okay, if your phone is in the top 1% of replacement times, how long have you been using it, right? So top 1% is more tiny right here, right? So that much. That's a top 1%, right? So top 1% means 0.01. Then we are using probability. What is the X value, right? Life replacement times, right? Equal to 0.01. Inequality greater than or equal to because right here, right? Make sense? Is it clear? Yeah. So top 1%, then we are using the right tail. So greater than or equal to. Yeah. Okay, let me take a picture and then I'm gonna show you everything in StatCrunch. You cannot see this one well. I'm so sorry. Oh my gosh, you do not see that, right? Okay. Sorry. All right, so we have a nice tip there. The terms top 10%, top 1%, top 5%. We did that earlier, right? Highest, largest, greatest, all indicate the area right tail. Yeah, that's a good point. So we are using inequality greater than or equal to right tail, right? Right tail. And the terms bottom, lowest one, smallest one, least, all indicate the area is in the left tail. Yeah, good point, right? Okay, so we are using the inequality less than or equal to, right? For the left tail. Clear? Okay. Now, this is the last concept for this section. We have z sub alpha, right? So we're going back to z score, right? But then look, we have a sub. We read. Let me write down. We read z sub alpha. Alpha. Correct? Alpha. All right. So what this means? Alpha is area of right tail. Alpha, right? Okay. Uh, then what is alpha? They say that alpha, we are using alpha to represent the chance of making an error in inference. So we're gonna get to that in chapter 9. Represent chance of making an error in inference. So we will use often alpha equal to 0.05 because we are using 0.05 in probability. That's unusual, right? Yeah. So that means it will be unusual to make this kind of error, 0.05, if we have a 0.05. Yeah. Okay. So we're gonna get to that chapter, kind of chapter 8. Yeah, more. But now let's talk about alpha is area of right tail. Okay. Related with the z-score, right? Okay. Now let's do this one. We have alpha is 0.05. We want to find the z-score, find the value of z sub alpha means alpha is given and then we want to find the z-score. So let me take a picture and then I'm going to show you how to find the z-score. 0.05, 0.01, 0.005. All right. So this is the last one. Oh, you cannot see again. All right.